Hello everyone, in this video I am going to explain geometrical isomerism. So before geometrical isomerism, first see this isomerism, classification of isomerism, already discussed. Isomers, organic isomers on the basis of criteria. Are the compounds have atoms connectivity in the same order? Atoms connectivity in the same order. For example, A, B, C, D. This is one type of atoms connectivity. A, C, B, D. This is another type of atoms connectivity. If atoms connectivity is different, your atoms connectivity different. Both have different atoms connectivity. Different atoms A, B, C, D, bond between AB, here bond between AC. Here there is no bond between AC, here there is no bond between AB. Atoms connectivity different. If atoms connectivity in the same order, they are called stereoisomers. Stereoisomers. If they have atoms connectivity in the same order, they are stereoisomers. If they do not have atoms connectivity in the same order, here no same order, this is not same order. If atoms connectivity is not in the same order, such isomers are called structural isomers. If atoms connectivity in the same order, they are stereoisomers. Atoms connectivity in the same order, yes, for that question stereoisomers have same atoms connectivity, so they are stereoisomer. Atoms connectivity are the compounds have atoms connectivity in the same order? No, because atoms connectivity is not same. Such isomers are called structural isomers. If atoms connectivity is different, such isomers are called structural isomer. Atoms connectivity same, they are called stereoisomers. So atoms connectivity same. For stereoisomers, atoms connectivity is same. Okay. Next, stereoisomers are again two types. Are the molecules interconvertible by the rotation of carbon-carbon single bond? If atoms are interconvertible by the rotation of carbon-carbon single bond. For example, A, B, C and D. A, B, C, D, like this. So, if this bond can be rotatable, then it comes to down. Free rotation is possible. So if atoms are interconvertible by the rotation of carbon-carbon single bond, free rotation is possible. They are called interconvertible by rotation about of single bond are called conformational isomers. Atoms cannot be interconvertible by the rotation of carbon-carbon bond, single bond. Here free rotation is not possible due to double bond formation or due to cycle formation, anything. Here interconversion is not possible due to a cycle formation with F atom or P atom. So due to this cycle, this bond cannot be rotatable. Due to this double bond, this bond cannot be rotatable. So due to 5 bond formation or due to cycle formation, if molecules are not interconvertible, such free rotation is not possible. Such isomers are called configurational isomers. Conformational isomers and configurational isomers. Configurational isomers are again two types. Okay. Is isomerism due to restricted rotation? If isomerism due to restricted rotation, such isomers are called geometrical isomers. Isomerism due to restricted rotation, yes, geometrical isomers. So other is optical isomers. Optical isomers. Okay, optical isomers are non-superimposable mirror images. I will explain. If they are optical isomers are non-superimposable mirror images, they are called enantiomers. Enantiomers. If optical isomers are non-superimposable, not mirror images, they are called not mirror images. Diastereomers. Diastereomers are not mirror images. Mirror images but non-superimposable enantiomers. Not mirror images are diastereomers. Mirror images but non-superimposable are enantiomers. I will explain all these things. So in previous videos, structural isomerism completed, stereoisomerism definition completed, conformational isomerism completed. In this video I will explain configurational isomerism. Configurational isomers. Okay, what are configurational isomers? So how do you define configurational isomers? Configurational isomers are stereoisomers. Configurational isomers are stereoisomers. They cannot be interconvertible. No, interconversion is not possible. So the stereoisomers which cannot be interconvertible by the rotation about single bond are called configurational isomers. Configurational isomers are again two types. They are geometrical isomers and optical isomers. If compounds have restricted rotation, configurational isomerism due to restricted rotation are called geometrical isomers. In geometrical isomers we have different kinds. This is the main class. Today class I am going to explain about all possible geometrical isomers. In this class, next video optical isomers. Okay, so take this one. Configurational isomers. So in stereoisomers, first kind conformational isomers, second kind configurational isomers. What are configurational isomers? The stereoisomers which cannot be interconvertible. Can be interconvertible or conformational isomers, cannot be interconvertible or configurational isomers. Okay, configurational isomers are two types, geometrical isomers and optical isomers. In that, first geometrical isomers. What are geometrical isomers? Geometrical isomers are configurational isomers. They are first of all configurational isomer. They belong to configurational isomers which exhibits isomerism due to restricted rotation of bonds are called geometrical isomers. Due to restricted rotation of bond are called geometrical isomers. Are called as geometrical isomers. Rotation is not possible. Why is rotation not possible and what is restricted rotation? See, sp2 carbon. For sp2 carbon, how many sp2 hybrid orbital? 3 sp2 hybrid orbital. These 3 sp2 hybrid orbital, here sp2 hybrid orbital with hydrogen, with sp2 hybrid orbital with hydrogen. This sp2 hybrid orbital with another carbon. It also contain same. So here overlapping like this. This is overlapping. Next here this carbon with one hydrogen, this carbon with one hydrogen. I am taking simple ethylene. Okay, so carbon here, hydrogen here, hydrogen here, here single bond, carbon here, hydrogen here, hydrogen here. Overlapping takes place. Overlapping like this. So after this overlapping rotation, here rotation is possible. About this axis rotation is possible. But this is which carbon? sp2 carbon. Carbon is which carbon? sp2 carbon. sp2 hybridization, sp2, sp2, sp2. So here 3 hybrid orbital sp2, sp2. It has pure unhybrid orbital. In sp2 hybridization, only how many orbital? 1s orbital, 2p orbital. Third p orbital is not participated in hybridization. This is pure p orbital which is not participated in hybridization. Okay. Now this hybrid orbital, this is sp2 hybrid orbital, this is what sp2, and this is what sp2, this is sp2 hybrid orbital, sp2 hybrid orbital. Okay, right. And this is what s orbital of hydrogen, s orbital of hydrogen, s orbital of hydrogen, s orbital of hydrogen. And this is what pure p orbital, unhybrid orbital. They overlap with each other. So how do they overlap? They overlap like this. This orbital overlapping takes place. Here overlapping takes place, and here also overlapping takes place like this. This is called pi bond. This is only one overlapping. Up and down, all this is only one overlapping. This is sigma bond. Sigma bond, pi bond. If only sigma bond is present, free rotation is possible. Only sigma bond rotation is possible. After formation of pi bond, rotation is restricted. So, due to pi bond restricted rotation due to pi bond. Here what? Restricted rotation due to pi bond. Restricted rotation due to pi bond. So this pi bond gives geometrical isomerism. Other cases same carbon with sp3 hybridization. Carbon sp3 hybridization. Here this carbon with how many sp3 hybrid orbital? 4 sp3 hybrid orbital. 4 sp3 hybrid orbital. This is also sp3 hybrid orbital like this. Okay, so this is one sigma bond between carbon and carbon atom. This is with any other atom. So just consider that maybe hydrogen atom. Here bond with hydrogen atom. Here bond with hydrogen atom. Bond with hydrogen. Bond with hydrogen. S orbital, s orbital, s orbital, s orbital of hydrogen, and all these are what? sp3, 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 sp3. This is also sp3. Okay. Now this sp3 hybrid orbital of one carbon with sp3 hybrid orbital of another carbon. Here another carbon, that is also sp3, 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 sp3. Okay. Here hydrogen. Okay. Right. Here overlapping takes place. Due to the cycle between these three carbon atoms, there is a formation of cycle like this. Okay. The cycle cannot rotate. Do not rotate. This cycle, formation of cycle, here stops rotation, possibility of rotation between this bond. The cycle formation, due to formation of cycle here, rotation is stopped here. This is called restricted rotation. This is said to be what? Restricted rotation due to cycle formation. Restricted rotation due to cycle formation, cycle or ring, due to formation of ring. This is restricted rotation. If configurational isomerism due to restricted rotation, that is called as geometrical isomerism. We will see geometrical isomerism in alkenes and cumulative alkenes, that means allenes, cycloalkenes and spiro compounds. First take this one.